Hey everyone, in this tutorial, we're going to implement multi-factor authentication in a Spring Boot application using Google Authenticator. Here is what we'll cover. We'll set up the multi-factor authentication flow from scratch, starting with generating a secret key, building the OTP URI, and producing a QR code that users can scan with Google Authenticator. Then we'll implement the confirmation step where the user verifies their authenticator app is working correctly before MFA gets fully enabled on their account. After that, we'll modify the login flow so that multi-factor authentication enabled users must provide a one-time code after entering their credentials. They will receive a temporary token, use it along with their OTP to complete login, and only then get their actual access token. Finally, we'll also look at a potential security vulnerability in this flow and how to address it. By the end of this tutorial, you'll have a fully working, production-ready multi-factor authentication system integrated into your Spring Boot application. Let's get started. Instead of starting from scratch, I am going to start with one of my previous projects. Here is the GitHub repository. This project focuses on token management using Redis. And obviously, this is Spring Boot project. This is actually an industry standard approach where the token is stored in a cache server. Usually, Redis is the tool of choice for managing these tokens. I also made a full video tutorial related to this repository. Let me show you my channel. Let's scroll down a little bit. Here it is. This video covers Spring security and managing JWT token with Redis. You can check that out if you want deeper dive. In that video, I explained in detail how to generate the JWT token and store it in Redis. Now, let's get back to the GitHub repository. Let me clone this, copy this URL. Next, I'll open my terminal. Usually, I store all of my projects in a dedicated projects directory. So, let's cd to that project directory. Now, I'll clone the repository here. Here, I entered the wrong command. It should be git clone and followed by the URL. Okay, the project is cloned. Let's open it in our IDE. Here, I am using IntelliJ IDEA. Now, open. Here is our project directory. And this is our project. And open it. Now, the project is opened in my IDE and it's downloading all the necessary dependencies. Let it download in the backend. And at this moment, before we dive into the code, let me give you a summary of the project so you can understand the big picture. I'll open my whiteboard tool to map this out. Here it is. Okay, now first, let's see how this token management flow works. Let's say we have a client. Next, we have our application server. This is our Spring Boot application. We also have a database. In my case, I am using PostgreSQL, but this could be MySQL, Oracle, or any database you prefer. Finally, we have our cache storage. As I mentioned, I am using Redis here. So, here is the scenario. We have the client, our Spring Boot application, and the database where user information is stored. This cache storage, this Redis cache storage is used specifically for holding temporary token data. Now, here is what actually happens. When a user sends a login request, let me show an arrow. When this login request is sent, the server communicates with database to fetch the user data. Then it verifies the credentials. If the verification is successful, the server issues a JWT token and also it stores that token in the Redis cache. Finally, it returns a response containing the token to the client. That's the simple login flow. Now, let's look at accessing a protected resource. I am making this client a little bit bigger here. This time, the client trying to access the protected resource. This time, he is adding the received access token in the request header. The client send a request with the token included in the authorization header. Upon receiving the request, our application first extracts the token from the header, then it verifies the token. It fetches the user information from the database to ensure they still exist. But also, it checks the cache to see if the token is present there. If the credentials are valid and token is found in the cache, the server returns the response with the protected data. So that's how the client accesses the protected resource. Now, let me show you how this is implemented in the application. Inside this src, main, Java, let's look at our controllers. The first one is the Auth controller. Here, we handle the login request. When the application receives this request, it simply calls login methods in the Auth service. Let's see what's inside that method. This method further calls authenticate user method, and this is the method that handles the actual user authentication. We are using this authenticate method that is from authentication manager, and it accepts username password authentication token as parameter. Behind the scenes, these handles fetching the user from the database, verifying the credentials, and checking the authorities. Once this is done, we set the security context and generate the token. After issuing the JWT, we need to store it. You can see here we call store token. If we look at the token repository, this is a class that is responsible for handling the queries related to Redis. Here we are using this Redis template to set the value using access key and the access token. Back to our auth service. Here, finally, we return the authentication response containing the access token, refresh token, and other necessary data. Now, what happens when a user requests a protected resource? When they request, they include the JWT in the authorization header. In our security configuration, we have this JWT authentication filter. This is the filter that executes for every request. First, it extracts the JWT, and then it extracts the username from the token. Behind the scene, it validates the token and extracts the username from the payload. Then it checks if this token exists in the cache. You can see here token repository.getAccessToken. It tries to fetch the token from Redis. If it exists, it can load the user details from the database. If the user is valid, it authenticates them, set the authentication details in the security context holder, and pass the request to the next filter. That's how simple the current implementation is. Now, let's try to run this project. But before running it, let me configure the database. Opening my application.yml file. Here, this is where the database configuration lives. I'm using PostgreSQL. This is the database URL. Let's update the database name. I want to name the database to MFA_demo. Everything else seems fine. However, for this DDL auto, I will change this to update. Instead of create drop, I will use update. Just a quick note, in production environment, you should never use update. You must set this to validate or none so it does not interfere with or break your production data. But for this tutorial, update is fine. Now, let's connect to the PostgreSQL to create this MFA demo database. For connecting with Postgres, I'm going to use the database tool that comes built in with IntelliJ IDEA. Let's navigate to this database tool window. Then click on this plus icon and data source, searching for PostgreSQL. So here in this window, every other settings is fine. I only need to provide the username and password. Now let's see if it's working. Click on this test connection button. Yes, it succeeded. So I'll click OK. Here is my Postgres database showing up in this database tool. Now let's create our database here. Right click on the connection, select new, and then database. The database name is MFA_demo. Let me make this window a little bit smaller so you can see everything. I made a typo here. It should be MFA_demo. Click OK. So our MFA demo database is created. Let's make the public schema visible. At this moment, this public schema does not contain any tables. They will be created automatically because let me open application.yml file. Here, we set this DDL auto to update. Beside PostgreSQL, I also need to connect to Redis. Here you see in this application configuration file, this is the configuration for Redis connection. So again, click on the plus icon in the database tool, then data source and search for Redis. I'll keep all these default value and click OK. Our Redis connection is showing here. Currently, we have database 0 selected and there is nothing saved yet. So we have our database connection complete and we have also configured our IDE to use as a tool for managing our data. Now let's start the project. Click on the play icon at the top. It looks like there is an error. It's failed to start. Let's see what is the problem is. Let's try to start it again. Okay, it's showing the error. Exception in initialize error. Let's check what is the issue. Let's try to delete the target folder from the project directory and try to start it again. It's the same error. Okay, let's take some help from AI. My intelligent idea comes with these AI tools. Now I can use this AI chat. I am going to use this AI assistant to understand what the problem is. Let's change the chat model to Claude 777 Sonnet. First, let's copy the error. Let's open the console. This is a build error. I'll copy this full message. And here in the chat window, here's my command. Explain what is the issue and how to solve this. And paste the log here. And send the chat. See how it provides the solution. It's saying your project is experiencing a compilation error. Okay. This is happening while compiling your Redis session management module. That means it's happening because I am trying to compile it using Java 24. Here is the suggested solution. The first one is check your Lombok version. Maybe my Lombok version is creating the issue. Let's check the pom.xml file. Here, I specified Java version 21. Let's check the dependency for Lombok. Maybe this version of Lombok does not support Java 24, which I might be learning. Let's update my Java JDK version. I am going to File from the navigation menu, then Project Structure. From this SDK dropdown, I am going to select the Java 21 Oracle JDK. Now apply the changes. Okay, done. Let's try to start this again and see what happens. Great. This time the project started successfully. Here in the console, we have this insert statement. This is because I have added a seeder to initially seed these users. Let's open this class, Redis Session Management Application class. This class contains our main method. Here I have added this command line runner and necessary logic to seed the database with initial user data. That's why whenever I run this application, the database gets populated. So far, it's good. But for now, I don't need this seeding. So let's remove this. And If we check the database, let's refresh the public schema. And we have one table now, users. Let's check the data. This admin user is added. Now, since we already have this user saved, let's try to access the application using Postman. In our home controller, we have this root endpoint. When we access it, it should return this hello world. Let's try to access that by opening Postman. Open a new tab. Our application is running on localhost 8080. I'm sending a GET request. See, we are getting 403 forbidden. That is because we have enabled Spring security, so this resource is protected by default and we cannot access it without authentication. Now, let's try to log in. I'll open a new tab. This will be post request. And what was the URL? It is in our Auth controller. The URL is this API/auth and then login. So localhost 8080, then API/auth/login. In the body, make sure row is selected and JSON is chosen from the drop-down. Here, as a JSON object, we need to provide the username and password. So the username is admin and password is also admin. Let's send the request. It's showing forbidden. That should not be the case. Let's see what is the problem is. In the console, here is the message. Request method get is not supported. Oh yeah. Here is the issue. I am sending a get request. It should be a post request. So let's change it to post and send the request again. See, in the response, we now have the data. We have this token. This is basically access token, the refresh token, and the user authorities. So we have this information here, but let's check the Redis. I'll close the console. Opening the database tool. Here, let's refresh Redis. See, we have these two keys, user access and user refresh. This user access key contains the access token and the other one contains refresh token. So these tokens are successfully saved in Redis. Now let's try to access the protected resource using this access token. I'll copy this token. Go back to the previous tab where we tried to access the hello world endpoint. Navigate to authorization. Select bearer token. And in the token field, paste the token. Now send the request. At this point, we are now able to access the hello world message. It's working perfectly. Now, let me show you what happens if we log out. New tab, copy this login URL and paste it here. I will change the URL to logout. In the authorization header, we still have this bearer token. Let's send the request. I have provided a wrong URL. It should be logout. Let's send it again. It's showing 403 forbidden again. Maybe I need to send it as post request. Let's check the code. Here is the auth controller. Yes, logout is a post request. So let's make sure we are sending as post request. And let's update a token. I'll copy this token and replace this token and send. Yes, this time we have the message. You have been signed out with a 200 status code. If we check the Redis database, let's refresh it. See, this access token and refresh token are now blacklisted. So we should no longer access the protected endpoint with the previous access token. If I try to access the protected resource again with the previous token, this time we are getting 403 forbidden. If we want to access this again, we need to log in and get the new token. Let's try to log in. A new token is generated. Let's copy this new access token. Go back to previous tab. Replace the token and send the request. Wow, we are now able to access the protected resource again. So that is how this Redis token management is currently working. Now let's implement two-factor authentication. Back to my whiteboard tool and let me explain what we're about to do. We'll implement two-factor authentication. Okay, here we'll use Google Authenticator to generate the one-time password or OTP. This two-factor authentication involves two steps. Before a user can verify their identity with an OTP, we first need to enable two-factor authentication for their account. To make this work, every user needs a unique secret key. Based on that secret key, we'll generate OTP auth URI. We need to import this URI into the Google Authenticator app so it can generate codes for us. However, manually adding this OTP URI can lead to errors, so we'll generate QR code instead. Scanning this code automatically imports the secret and we can then get the OTP code from the app. After enabling 2FA, the next is enforcing it during login. Now first, let's implement this setup process. Let's map out the exact steps on a diagram. Here we have our client again. I'll make this a little bit colorful. I'll giving the client a red color, and for Spring Boot application, let's say it's green. This is just make it more visible. To enable 2FA, the user must already be authenticated. The authenticated client will send a post request to the application. Let's say the API endpoint is MFA/setup. Upon receiving this request, the Spring Boot server performs the necessary verifications. Once verified, it generates a secret key for the user and corresponding QR code. It's become a little bit congested here. Let's adjust their positions to keep these elements closer. Next, it saves the secret key to the database. Okay, in our user table, we'll have an enable flag. At this specific moment, that flag remains false. 2FA is not enabled yet. We're just saving the secret. Then the application returns the QR code to the client. The user scans this code to import the key, and then using the client, that user sends another post request to confirm it. Let's say the endpoint is MFA/confirm. This request includes the OTP code generated by the Google Authenticator app. When the Spring Boot application receives this request, it fetches the user's secret key from the database and verifies the OTP. It verifies it. It sets the enable flag to true. At the same time, it deletes all tokens from the cache. This essentially forces a logout. Finally, it sends a success message to the user. This is how this whole process works for enabling the multi-factor authentication for the user. Now, let's get back to the IDE. Let's stop this project and open the pom.xml file. Here, we need to add two more dependencies for our project. Back to the browser, in a new tab. For adding Maven dependency, search for Maven Central. Here, I'm looking for this URL, central.sonatype.com. Let's enter into this. Here, in the search box, search for Google Auth. There are a couple of dependencies showing up. Okay, this search result is not showing the exact dependency that I want to include. Let's search with a different term. The dependency will be from Warren Strange. So let's search for Warren Strange Google Auth. Yeah, here it is. I want to include this dependency from com.warrenstrange. Let's enter into this. Make sure Maven is selected from this dropdown. I'm going to include this dependency, and here is the version. Let's copy this. Back to the IDE. Scroll down to the dependency section and let's paste the dependency. This dependency is for Google Authentication. It will handle the secret key generation and the validation mechanism. Additionally, for generating the QR code, we need to add another dependency. Back to the browser. Now search for Java SE. I need this one from com.google.zxing. I will use this dependency. This is for graphics and image processing. Let's get inside and copy the dependency declaration. In our pom.xml file, paste this. Now we need to load our Maven dependencies. Click this refresh icon here. It will synchronize the Maven changes. Our project is updated and you see this red mark has gone. Now let's do the setup process. Let's close all these tabs. Inside the controller package, I am going to create a new Java class. I'll name it MFA Controller. I will annotate this with REST controller. Also, I'll add a request mapping. I'll call this /API/MFA. And here, add the loombook annotation, required arts constructor. Now, inside this controller, we'll provide a necessary method for setting up multi-factor authentication for the user. First, we'll have a post mapping. The URL for post mapping will be /setup. So the final URL will be /API/MFA/setup. It will be public method and the return type will be response entity. The type will be MFA setup response. I will create this class shortly. I will call this method setup MFA. It accepts principal object. This principal object actually carries the information of the authenticated user. Okay, let's create this MFA setup response in our DTO package. At this point, we have couple of classes inside this DTO package. Let's refactor this. Inside this DTO package, I am creating a new package. Let's say the name of the package is request. Inside this request package, we'll put all the details that are related to request. So login request, refresh token request, and registration request. Select all of these and drag them to this request package and refactor. Again, inside this DTO, I'll create another package. I'll name it response. I'll put the remaining classes, this authentication response and token pair inside this response package. Great. Now, I'll create this MFA setup response. Here, I made a typing mistake. Let's remove this and rewrite this again. This will be MFA setup response. Now, I'll create this class inside the response package. I'm creating a new Java class. Name this MFA setup response. This MFA setup response is what the user will get as response for the setup API call. In the response, the user will get the secret key, a QR code URI, and the actual image of the QR code. Let's create a private field. It will be string and it will be for the secret key. I'll call it secret. Then another private field, string QR code URI. And also we need a field for QR code image. Private string QR code image. The user will get this QR code image as a base64 encoded string. Here, use the loombook annotation, getter, and add another annotation, builder. I'll use this builder to populate these fields. Okay, let's close this. And here in MFA Controller, import this class. Now, for doing this MFA setup, I need to create a service where this MFA related logic will be located. Let's open the sidebar. Inside this service package, create a new Java class. I'll name this MFA Service. Annotate this with the service annotation. This class will contain the method for MFA setup and first-time verification to confirm multi-factor authentication. It will also include code for MFA verification during login. Let's create those methods. The first one is for MFA setup. It's a public method. The response will be MFA setup response. I'll name it setup MFA and it will accept the username. Here, we'll do a couple of things. First, we need to query the database to check if the user exists with this username. So, user repository. I'm just typing user repository here. You see, my IDE has automatically added these as dependency. It's a great feature of IntelliJ IDEA. I can just type the name of the class and it automatically includes that field. Using this constructor, we are injecting this dependency. Since I am using Loombook, I don't actually need a constructor. Instead, here, let's use another Loombook annotation, required args constructor. Now, in this user repository, we'll call find by username and pass the username. If the user is not found, then it will throw a username not found exception with the message user not found. Let's store this returned user in a variable named user. If this user exists, then our next step is to check if multi-factor authentication is enabled for this user. So if user.isMFA enabled, this is actually showing an error because we have not added this field in our user entity. Let's modify our entity and add the necessary properties there. Open our model, then user. This is our user class. Here, I will add two additional fields. First one is a Boolean field. So private Boolean MFA enabled. Add column annotation to set the name. And also add a column definition to set the default value to false. We need another field to store the secret key. So private string MFA secret. Again, add a column name. So for this, we actually need to provide the setter and getter. I am using Loombook, so I don't need to add this manually. So let's remove all the previous setter and getters. This will make class a little bit cleaner. And here in this user class, add the Loombook annotations, setter, getter. Also, I will add a special annotation that is dynamic update. With this dynamic update annotation, we ensure that the database only updates the columns where the value has actually changed. If you want to learn more about this specific annotation, you can check out my other video where I explain this in detail. You can check this link in the screen and also you can find this in my channel. Back to the MFA service, you can see the error is gone. So if multi-factor authentication is already enabled for the user, we should not allow them to set it up again. I will throw a new illegal state exception with the message MFA already enabled. Here we are checking if MFA is already enabled. If MFA is not enabled, we will generate the secret key and save it. At this point, we are saving the secret key, but multi-factor authentication is not yet enabled. We will only enable it after the confirmation setup. To handle these MFA-related operations, I will create a new utility class. Let's inject it here first. Private, final, TOTP util. And here, for the secret, I'll call TOTP util dot generate secret. So here it's showing this error because our TOTP util, this class is not exist yet. Now let's create this class. Inside my root package, I'm going to create a new package named util. Inside this util package, I am creating a new Java class named TOTP UTIL. I'll annotate this with component so that I can inject it automatically. This class will be responsible for generating the OTP secret key, building the OTP auth URI needed for Google Authenticator, generating the QR code image, and verifying the OTP code. Let's implement these one by one. First, we need some properties. I'll create a private field. Final. Here, I'm going to initialize Google Authenticator. I'll name this Auth and initialize it. This is the brain that knows how to create secret and check codes. I also need the application name. I'll get this from application.yml file. Open application.yml at the bottom. Let's define a new property, MFA, then app, and name. I'll call this MFA demo. Back to TOTP UTIL. Here, I'll use the value annotation to inject that property into the app name. Now, let's create the methods. The first one is for generating the secret. It returns a string, generates secret, and it returns here call gauth.createCredentials.getKey. Now, our next method is for building the OTP auth URI. This is the URI that we need to import to Google Authenticator. It accepts the username and the secret. Here, the format of the OTP auth URI looks like this. OTP auth, then colon, // then TOTP // then we need to provide the name of the application, then colon, provide the username, then after a question mark, we need to provide the secret. So return. Here, I'll use string formatter to build this. Let's copy this. Paste that URL. Here, I will replace the placeholders. First one is name for the application. Provide the placeholder %s and it will be replaced by, here provide a comma. It will be replaced by app name. I want to make it URL safe, so use URL encoder dot encode, provide the app name, and I want it to UTF-8 encoded. Next, provide a placeholder for username. It will be replaced by username. Next, I'll replace the secret key. It will be here. My IDE is suggesting the code. Press tab to accept it. Next is the method for generating the QR code image. It returns a base64 encoded string. Name generate QR code base64. It accepts OTP auth URI. Inside this method, I'll create a QR code writer, initialize it. Then we need bit matrix. We need this before creating the actual image file. Use QR code writer to encode our URI to a bit matrix. Pass the OTP URI. Then the format, barcode format dot QR code. Then the dimension, let's say 200 by 200. We need to wrap this inside a try-catch block. If there is an exception, I'll throw runtime exception. Now, we need to write this matrix to an output stream. To get this to the browser, I'll create a byte array output stream named PNG output stream. This acts as a temporary bucket in memory to hold the image bytes. To write the data, I'll use matrix to image writer dot write stream. Pass the matrix, then the format PNG and output stream. Finally, convert this to base64 string. I will use base64.getEncoder.encode to string. Provide our PNG output stream as byte array and return. Before returning, I will add the data URI prefix. This allows us to render the image directly in the browser. The final method is for code verification. It accepts the secret and the code. The code comes as a string, but the library accepts an integer. So we need to parse this code to integer. Then return gauth.authorize, pass secret and code. That's all for our utility. Back to MFA service. Let's import the class. Now inside setup MFA method, now here with this generate secret method, the secret is generated and this stored in this secret variable. After generating the secret, we need to save it for the user. Set the MFA secret of the user and save. Here, I want to mention one thing. Saving the secret in plain text like this is dangerous. You must encrypt this string before saving it to the database. For now, let's add a to-do comment. Implement secret key encryption. I'll show you how to implement that in a moment. Next, generate the OTP URI, passing the username and secret. Store it to a variable. Then we'll generate a QR code image. We'll generate the QR code for OTP auth URI. Finally, return the response using the builder. We'll pass the secret, the URI, and QR code image, and build. This completes the setup method. Our next step will be handling the confirmation. But before that, let me show you how to build the encryptor for this secret key. For encryption and decryption, we are going to use AES-256 in GCM mode because it's the industry standard for security. Let's start by creating a service. Inside the service package, create a new Java class named Encryption Service. Annotate this with service annotation. Now, I'll start the encrypt method. We'll take a plain string and we want to return a safe encrypted string. Here, first, we need a cipher instance. Make sure to import this cipher from JavaX crypto. Call cipher.getInstance. Here, provide our algorithm string, that is AES-GCM with no padding. I'm using GCM because it provides both encryption and integrity checks. Instead of hard coding this algorithm string here, let's extract this to a constant. Name it algorithm. Also, let's add some other standards. Another constant. This is for initialization vector length. Set it to 12 byte for GCM. This is the NIST recommendation for GCM. Add another constant. This one is for tag length. Use 128-bit for maximum security. Alright, back to the encrypt method. Here, add the exception to the method signature. Now, AES-GCM requires a unique initialization vector for every single encryption. It needs to be unique for every single encryption. Create a byte array for the initialization vector. We need to fill this array with random bytes. Creating a secure random instance every time is actually quite expensive and slow. Let's define a static field for this secure random instance. This secure random is thread safe, so we only need one instance for the whole application. This will speed things up significantly. Now, here, replace it with secure random. Perfect. Now, we have our random initialization vector. Next, we need to initialize the cipher with the secret key. At this point, we need to load the secret key. Here, declare a field, private, string. I'll name this master secret key. Secret key. We'll grab the key from application.yml using the value annotation. So open application.yml file. Here, declare a new property, app security encryption key. Let's generate the key. Open the terminal. Here, for generating the key, I'll use OpenSSL. Then rand for random data. I need it base 64 encoded, and then provide the length in bytes. I need 256 bit, which is 32 bytes. Press enter. Here is the key generated. Copy this and paste it in our application YML file. Back to the encryption service. Here, in this value annotation, provide the name of the property. Here, since the key is stored as base 64 string, we need to decode it into row bytes once the app starts. To do this, add a method, void init. Before this method, let's add an annotation, post construct. This will ensure that this method will run automatically exactly once right after Spring starts up. Here, we need to decode the base 64 string back to the byte array, store it to a variable named decoded key. Finally, we need to wrap this byte into secret key spec. Pass the decoded key and the name of the algorithm, that is AES. We need to store this as a variable. Let's declare it as field variable. Private secret key. This is from JavaX Crypto. And in the init method, this secret key spec, this will be stored in this secret key. Doing this here is huge performance win. That means we convert the key only once at startup instead of wasting CPU cycles by reprocessing it every single time a user sends us the data. Now back to the encrypt method. Here, initialize the cipher in encrypt mode, pass the secret key, and use GCM parameter spec to tell Java to use this specific random initialization vector for this specific message. And again, add an exception to the method signature. Now encrypt the data. Cipher.doFinal. Provide the plain text dot get bytes. Here, we need to convert the string to UTF bytes to ensure it works on any operating system. Standard charset.utf8 and store it as byte array named ciphertext and add exception to method signature. Next, we need to pack the data. This is crucial part. To decrypt later, we need the initialization vector. Since this initialization vector is unique for each encryption, so we'll attach it to the front of encrypted data. So create a buffer, byte buffer dot allocate. Here, the total allocation length will be the length of the initialization vector plus the length of the ciphertext. Then first put this initialization vector, then put the encrypted data and return the whole package as a base 64 string. Return base 64.getEncoder, then encode to string. This is bytebuffer.array. That's for encrypting. As we have encrypted the data, we also need a method to decrypt it. Create another method, public string decrypt. It accepts encrypted text. Decryption is the reverse of encryption. First, convert the encrypted text to a byte array. Store it to a variable named decoded bytes. Next, we need to wrap this decoded byte into a byte buffer. While packaging the data for encryption, first we have provided the initialization vector and then the ciphertext. So here we will separate these two parts. First, let's extract the initialization vector. Create a new byte array of the length of the initialization vector. Now use bytebuffer.get and pass the byte array of initialization vector. This reads the next 12 bytes from the buffer and copies them directly into the initialization vector array we just created. This operation also advances the buffer's position by 12 bytes. So it's ready to read the encrypted message next. Now for the encrypted message, declare another byte array for holding the ciphertext, new byte, and for the length, byte buffer dot. Since we don't know its length in advance, we are using the remaining method. This calculates exactly how many bytes are left in the buffer after the initialization vector. We are using that number to allocate an array of the perfect size. Let's change this b to smaller case. Then we just need to copy the rest of the data into it. This grabs everything left in the buffer, including the authentication tag. So we have the complete package ready for decryption. Create an instance of cipher.getInstance and pass the algorithm. Then initialize the cipher in decrypt mode. Provide the secret key and use that extracted initialization vector in GCM parameter spec. Now we'll do the decryption. Declare a byte array for storing the decrypted plain text, and finally call cipher.doFinal and provide the cipher text. Here, this AES-GCM performs a check. If anyone tampered with the data, this line throws an exception. If it passes, we get our original text back. Now, I'll wrap this whole thing inside try-catch block. Try, paste the code here, and if there are any exceptions, we'll catch that exception and throw a runtime exception with a message decryption failed along with the exception itself, and return the decrypted text byte as a string. New string. Here we'll provide the byte array of the plain text that we have defined. Let's rename this to plain text byte. Now inside constructor of string, provide the plain text byte and return it as UTF-8 charset. That's all for this encryption service. Here it's showing an error. Let's check this. I forgot to add a semicolon. Okay. So this is our encryption service. Back to the MFA service. Here, instead of storing this secret in the database for the user as a plain text, I am going to encrypt it. To do this, let's rename this variable from secret to row secret. Next, I'll create another variable to hold the encrypted secret. I'll name this encrypted secret. To encrypt this secret, this plain text, I need to inject the encryption service. There is a great shortcut in IntelliJ IDEA for this. I can just type the name of the class, encryption service. See, it's suggesting it right here. If we select that, you can see at the top of the file, it has already added this encryption service as a private final field. And thanks to our required args constructor, it is automatically injected. Let's go back down to where we are working. Here, we call encryption service dot encrypt, passing this raw secret. We also need to add exception to the method signature. Down here for user.mfa secret, instead of the raw secret, we are going to save our encrypted secret. Okay, that's all for our setup MFA method. Here, I also do some small changes. For this user variable, instead of using the var keyword, let's use the actual class name, which is user. This makes the variable declaration consistent with our other declarations. Now, back to the MFA controller. Inside this setup MFA method, we are going to call our MFA service. Again, I am just typing the name MFA service, and IntelliJ IDEA automatically adds the variable to inject it into the controller. We'll call MFA service dot setup MFA. Here we need to pass the username. Since we are accepting principal object, this holds the authenticated user's information. So we can easily get the username by calling principal.getName. I'll store the result in a variable. The data type will be MFA setup response, and I'll name it response. We need to add an exception to the method signature. Finally, return response entity.ok and pass the response as the body. Okay, let's handle the setup process. Now, let's start the application and see this in action. Here, it's failed to compile. Java cannot find symbol, variable secret. Okay, let's click here to get where this error occurred. Okay, here we need to fix this reference. Earlier, we renamed the variable to raw secret, so the name secret no longer exists here. Down here, for building the OTP auth URI, we need to provide the raw secret, not the encrypted one. And again, down here in the response builder, we must provide the raw secret. Okay, I think it's fixed. Let's try to start the project again. Our project has started. Here in the logs, you can see Hibernate executing a SQL script to modify the table. It has added MFA underscore enabled column with default value of false and another column named MFA underscore secret. Let's check this in the database. I'll refresh the view. Here in our user table, if you open this, you can see there are two additional columns, MFA enabled and MFA secret. And the default value for this enabled is set to false. Great. Our application is running, so let's test this using Postman. I'm opening the Postman. First, let's log into the application. This is the URL for the login. I'll send the request. We have logged in successfully and our JWT token is generated. Let's copy this token. Now, we'll set up our multi-factor authentication for this admin user. I'll open a new tab. This will be post request. The URL is localhost 8080 API MFA setup. In the authorization header, select bearer token, update it with the new token we just copied, and send the request. See, in the response, we're getting the secret key, the OTP URI, and the QR code image, which is base64 encoded. Before doing anything else, let's see what is actually saved in the database. Back to our database tool. I'll refresh the user table. Look at the MFA secret columns. This is encrypted data. We are not storing the plain text secret we saw in the Postman. We are storing the encrypted value. This is much more secure. Now, the QR code has generated and I need to scan it with my Google Authenticator app. To view the actual image, since I don't have a front-end UI for this backend application, we can use the browser. In real-world scenario, you might have front-end using React, HTML or something else that would render this easily. But since we just have the data, let's copy this entire base64 encoded string. I'll open the new tab in the browser, paste the data URI directly into the address bar and hit enter. Our QR code is now rendering right here. Now I am going to scan this QR code. So here, open Google Authenticator app. As you can see my mobile screen, let's tap on this plus icon and select scan a QR code. Now point the camera at the QR code displayed in our browser. The secret key is instantly imported and our account is added. Here, it has already started to generate the one-time passwords. Google Authenticator actually generates a new OTP code every 30 seconds. Right above the code, you can see the name of the application and the username that we configured earlier in our OTP auth URI. Now, we can use this OTP. Since this code refreshes every 30 seconds, we need to use it within that valid time window. We have now successfully set up Google Authenticator for our multi-factor authentication. Let's check our technical diagram again. We have completed the setup phase here. During the setup, we generated the secret, stored it in the database, rendered the QR code, and successfully imported that QR code into our Google Authenticator app. Our next step is to confirm this multi-factor authentication. To do that, we will send a request to a new endpoint. This request will include the one-time password that we are getting from the Google Authenticator app. When the Spring Boot server receives this token, what it will do? First, it will fetch the secret key from the database. Since we encrypted it earlier, we actually need to decrypt it first. Then, we will verify the incoming OTP against that decrypted secret. If it is valid, we will delete all the tokens stored in the cache that will eventually forcefully log out the user. This forces the user to log back in using their newly enabled two-factor authentication. Finally, we'll return a success response. Let's implement this. I'll close all the other tabs. Let's start from MFA Controller. Right below our setup method, our next method will be for confirmation. This will be post mapping, map to confirm. Let's create a new public method. It will return a response entity. Give it type string because we'll just provide a plain string message. I'll name it confirm MFA. It accepts the principal object which contains the authenticated user's information. Also, we'll accept the request body. The type will be MFA confirm request. Let's create this MFA confirm request class now. Inside our D2 package, under the request subpackage, create a new Java class, name it MFA confirm request. This class will only contain one field, that is code, private string code. Let's add validation annotation here, not blank. Make sure you import it from Jakarta validation constraint. Provide a message, MFA code cannot be blank. Also, let's add a pattern annotation. I'll use a regular expression to ensure the code is exactly 6 digits. If the pattern does not match, provide the message, MFA code must be 6 digits. Finally, let's add the Lombok annotation, getter and setter. That's it. Let's close this, go back to MFA controller and import this class. Inside the controller method, what we'll do is call MFA Service dot confirm MFA. We'll pass the principal and the MFA confirm request. We have not created this method in the service yet. Let's let the IDE to generate this method in the MFA service. Okay, the method is created in our MFA service. Right now, the return type is void, but let's change it so it returns a boolean. I'll move this parameter to next line for better readability. Inside the confirm MFA method, the first thing we'll do is fetch the user from the database. I'll use the same fetching logic that we have used in our setup MFA method. Let's copy this block and paste it here in our confirm MFA method. Instead of passing the entire principal object, let's just accept the username as a string. Let's modify the method call in our MFA controller. Here, we are calling this confirm MFA method. Here, we'll provide principal.getName as the first argument. Okay, back to the MFA service. After retrieving the user from the database, the very first thing we check if MFA is already enabled. If it is enabled, we don't need to set it up again. So here we'll throw a new runtime exception. Our next step is to check if the MFA secret for that user is actually saved in the database. We need that secret generated in the previous step for verification. So check if user.getMFASecret is null. If this is null, we need to throw another runtime exception with message MFA secret is not set up for the user. If everything is fine, meaning MFA is not enabled yet, but the secret is safely stored, our next step is to verify the code. We have stored the encrypted value of the secret in our database, so we need to decrypt it first. Let's decrypt the secret. Call encryption service.decrypt and provide the encrypted text, which is user.getMFASecret. Store this in a string named decrypted secret. Now it's time to verify the code. Call TOTP code. The first argument will be the decrypted value of the secret. The second argument is the code we received from the client. So confirm request.getCode. Let's wrap this in an if statement. If this verification returns false, meaning the code is not valid, we'll throw a runtime exception with the message invalid MFA code. If the code is valid, then we'll set the MFA enable flag to true and save the user. Finally, return true. Now back to the MFA controller. Let's store the response value from the confirm MFA into Boolean variable. Add if statement. If not confirmed, will return a response entity with the status http status.unauthorized and a body message of invalid MFA code. Please note that since our service throws an exception on an invalid code, these blocks act as a safeguard. If it is true, then we need to forcefully log the user out. We need to inject the auth service. Again, just by typing the name auth service, our IDE will automatically inject it for us. Call auth service.logout. Finally, return response entity.ok with the message MFA confirmed successfully. Okay, now let's test this out. I'll restart the server. Back to Postman. Since some time has passed, let's log in again. Here is our new token. Let's copy this access token. In a new tab, we'll make a post request for confirmation. The URL is localhost 8080 API MFA confirm. First, we need to set the authorization header, select bearer token and paste the new access token. In the body, make sure row is selected and JSON is chosen from the drop-down. Provide JSON object with the code field. To get the code, I am opening my Google Authenticator app. Here is a generated code. Let's type it in here and send the request. See, we get the response. MFA confirmed successfully. Let's check what happened in the database. Here in the IDE console, you can see Hibernate fired an update statement to modify the user MFA status. If we check the database, refresh the user table, you see this MFA enabled value is now set to true. Great. We have successfully enabled two-factor authentication for the user. So our setup stage is complete. Our next step will be to restrict the login process. We will force the user who have successfully enabled multi-factor authentication to provide their authentication code during login. Now, here is the flow of how that works. First, looking at the diagram, you see we have the client, our Spring Boot server, our PostgreSQL database, and our Redis cache for storing the tokens. Since our user has enabled MFA, they will first try to authenticate using their username and password. Upon receiving this request, our Spring Boot application will query the Postgres database to fetch the user and their MFA status. It will verify their credentials and then check if multi-factor authentication is enabled. If it's not enabled, we just send a standard response containing the access token and refresh token. There's no further steps required for the user without MFA. But if multi-factor authentication is enabled, we will generate a unique identifier. This will act as temporary token and we'll store it in the Redis cache. Then we'll return a response to the client with an MFA required flag set to true. We'll also include that unique temporary token we just stored in the Redis, but we will not include any access token or refresh token. Once the client receives that response, the next stage begins. The client will send another request for verification. This request will contain the temporary MFA tokens and the one-time password generated by Google Authenticator app. Upon receiving this, our Spring Boot server will check the unique identifier and verify the OTP. If everything is valid, it will issue the final JSON web token and return it to the client. That's how this multi-factor authentication flow will work for our application. Let's implement this in our code. Now, let's go back to our IDE. Authentication related operations are handled by our Auth controller. Let's close all of the tabs and open our Auth controller. Here we have this login endpoint. This method is responsible for authenticating the user. It's calling auth service.login. Let's open that. This again calls this authenticate user method. This method does the authentication operations and returns the authentication response. Let's check this authentication response. Here we are getting token, refresh token, username and authorities. Along with them, I need to add a few more properties to handle the MFA flow. First, we need the temporary token that is generated if multi-factor authentication is enabled. We also need a Boolean field indicating if MFA is enabled and a final Boolean field for checking if MFA is verified. We'll need those three additional fields for our response. Back to our auth service. Here, first, we are authenticating the user. If the user is authenticated, it means the requested credentials are valid. At this point, we need to get the user information from the database to check their MFA status. So let's create a user object. Make sure this is imported from our model package. So fetch the user. To fetch the user, I'll use user repository.find by username. If the user does not exist, then throw a username not found exception. Let's import this class. If the user is found, the first thing we'll check if multi-factor authentication is enabled. If it's enabled, we need to do a couple of things. We need to generate the unique identifier. We will use that as our temporary token. Then we'll store this to the Redis cache. Finally, we'll send a response along with these multi-factor authentication token. Let's implement them one by one. First, generate the temporary token. I'll call it MFA token. We'll generate this using uuid.randomuid.toString. Let's import this uuid class. Next step is to storing the token. For storing the token in the Redis, we are using token repository. As I have mentioned it before, here I am using token repository to do the Redis related operations. So here we'll use token repository.store MFA token. We'll pass our MFA token and the username. This method does not exist yet in our token repository. Let's create that method. Let's open token repository. This repository handles the necessary queries for doing operations in our Redis cache. Below other tokens method, I will create new method for storing our MFA token. It will be public, return void, and store MFA token. It accepts the MFA token and the username. First, we need to define a key. A key is the identifier used to store and retrieve data from Redis. I'll name this variable access key. This will equal, we will start with a prefix for the key, MFA underscore pending, followed by a colon. Let's concatenate with the MFA token. Now, let's store the value in Redis. Provide the access key, and for the value, provide the username. After that, I'll set an expiration time on this Redis key. Pass the access key, then provide the duration until it will expire. This will expire after 5 minutes. I will provide this value in milliseconds. 5 minutes is equals to 300,000 milliseconds. And lastly, provide the time unit. It will be millisecond. Now, here I'll do some refactoring. Instead of hard coding this prefix for access key, I will extract this into a constant. Let's name it MFA underscore pending underscore prefix. Here at the top of the file, this constant is now placed by the IDE. Let's organize it. I'll move this down to the bottom of our other fields and make it private. And I'll also extract this timeout value to separate field variable. I want to name this MFA token expiration. At the top of the class, right after our expiration fields are defined, let's create our new variable. I'll define the value of this variable in our application.yml file, and we'll use the value annotation here to inject that value. Let's define that value. Open our application.yml file. Inside the app properties, I will add MFA token expiration and set this value to 300,000 milliseconds. And here, the value annotation provide the property name. Now, back to our auth service. Our token is stored in Redis. Now, we need to return the response. In the authentication response, let's add Lombok builder annotation so we can easily create the object. Back to auth service, we'll return authentication response dot builder, set MFA required to true. There is no suggestion related to MFA required. Let's check authentication response again. Actually, here I want to rename this is MFA enabled to MFA required. Then let's rename the other fields MFA verified. Now in auth service, set MFA required to true. Set MFA verified to false because we are just trying to log in and MFA is not verified yet. Provide the MFA token we just generated and build. So this is the case if multi-factor authentication is enabled. Otherwise, if MFA is not enabled, we actually issue the real token. It sets the authentication to the security context, generate the token pair, store the token in Redis, and finally return the authentication response. It's showing an error here because we need to modify this return statement since we just added the builder method. Let's remove the old statement. It will be authentication response dot builder. First, we'll set the access token. It will be token pair dot get access token. Then we need to set the refresh token and then provide the username and authorities. Actually, we do not need to provide the username and authorities in the payload. You can always get it from the database, and sometimes providing this in the response can be security leak if not needed. It all depends on the requirement, but for now, I don't want to include this in my response. Let's actually remove this username and authorities from the authentication response object. It's much cleaner now. Also, let's rename this token to access token. Back to our service, we need to do a couple of refactoring here. It's showing an error, so change it to access token, and the username and authorities fields are no longer available since we just removed them. That was for login. We have another place to update. For the refresh token method, we need to update a response similarly. Let's replace this new declaration with the builder, authentication.builder, then provide the access token, refresh token, and build. That handles what happens when the user requests to log in. If multi-factor authentication is enabled, we need to send another request to verify it. So inside the auth controller, I am adding another post mapping. It's for verification. Verify MFA. Create a public method, returns response entity of type authentication response. Name it verify MFA. It accepts a request body. I just remembered I missed one thing in our MFA controller earlier. While confirming, we are accepting this request body, but without the valid annotation, the validation rules we provided in MFA confirm request actually become useless. So let's add a valid annotation before the request body in the MFA controller. This was a small mistake and it happens during development, so we need to be careful. Okay, back to the auth controller. Here, before the request body, I will also add the valid annotation because we'll add some verification rules. The type will be verification request. Let's create this verification request class. Inside the DTO request package, create a new Java class and name this verification request. This will have two fields, MFA token and code. Let's add validation rules, not blank, with a message MFA token cannot be blank And for the code, not blank with the message, verification code cannot be blank. Add getter and setter. Back to Auth controller, import the verification request. From here, we'll call Auth service dot verify MFA and pass the verify request. We need to create this method in our Auth service. Let's use our IDE to generate it. The method has generated in our Auth service. Let's change the return type from void to authentication response. Here, first I'll query Redis to get the stored token. I'm using token repository dot get MFA token. And for the parameter, let's copy this parameter name. Here, I'm passing the verification request dot get MFA token as the parameter. We need to create this method in our token repository. It will return a string. The logic will be first define the access key, MFA pending, and then MFA token, then return get token and pass the access key. Here, this get token method retrieves the value from Redis using the key. Back to the Auth service. This get MFA token method returns a string. Let's store this result that we received to a variable of type string and name it username. Now, I need to query the database to get the user. I'll store it as a user variable. For the database query, I'll use user repository dot find by username and pass the username. If that user is not found, then I will throw a username not found exception. If the user is available in the database, then we need to check if the user has enabled multi-factor authentication. If it's not enabled, we will not proceed. I'll throw a runtime exception with the message MFA is not enabled for the user, providing the username. We also need to check if the MFA secret is actually stored in the database for that user. If the stored multi-factor authentication secret is null, again, we are not going to proceed further. I'll throw a runtime exception. So here we are getting the user from the database. We are checking if multi-factor authentication is enabled, and finally we are checking if the secret is stored. If everything is okay, then our next step is to verify this token. For that, I'll use TOTP util verify code, and here we need to pass the secret and the code we received. For the secret, we actually save the encrypted value for the user. So here we need to pass the decrypted secret value. First, we need to decrypt this. I'll store this in a string named decrypted secret. To decrypt it, I'll call encryption service dot decrypt. Then we need to pass the encrypted secret that we get from the database. Inside this verify code method, pass the decrypted secret and the code. Let's wrap this in an if statement. If verification fails, meaning it's invalid, then we are not going to proceed. I'll throw another runtime exception with the message invalid MFA code for the user. If this is valid, then we will do a couple of things. Let's write down step by step what we are going to do. We will authenticate the user, then generate the token pair, that is access token and refresh token. Then we need to store the tokens in the Redis cache. And at the final stage, we need to remove the temporary MFA token from Redis. Let's do this one by one. First, start with authenticating the user. For authentication, I'll use username password authentication token. Here I need to provide a couple of properties: the principal, credentials, and authorities. For the principal, let's build our user details object, create a new variable, user details. This equals user. Make sure it is from org Spring Framework Security Core User Details user. Build this with username. Provide the username of the user stored in the database. using user.getUsername. Then we need to provide a password. Here we pass the hashed password from the database. Then we need to provide the authorities. In our user class, we have this role field. I'll use this role as our authority. Back to our service. In the authorities method, provide the user.getRole.name. And finally, build. Now, in our username password authentication token, first pass the user details as the principal. Then we need to provide credentials. Here, I'm not going to provide any, so let's give it null. Then provide the authorities using user details.getAuthorities. Store this into a new authentication variable. Make sure this is from WARG Spring Framework Security Core Authentication. Next, we'll generate the token pair. Call JWT token provider dot generate token pair and pass the authentication object. Store the return value in a token pair variable. Then I'll store this pair in Redis. I'll call token repository dot store token. To store the token in this method, we need to provide the username, access token, refresh token, the access token expiration, and refresh token expiration time. Let's give them one by one. First, the username. We'll use user details, u.getUsername, then the access token. Next one is the refresh token, then access token expiration, and finally, the refresh token expiration. Finally, we need to remove the temporary multi-factor authentication token from Redis. Call token repository dot remove MFA token. My IDE is suggesting an autocomplete. I'll accept it. At this point, our remove MFA token method is not available yet. Let's create this method in our token repository. It returns void, build the access key, and delete it from Redis. Okay, it's done. Back to the auth service. Now we'll return the authentication response. Call authentication response dot builder, set the access token, then refresh token, set MFA verified to true, MFA required is also true, and build. So this is for verifying the MFA token. Now back to the auth controller. Here, store the response to the variable, type authentication response, name this response. I'll return response entity.ok and pass the response. Okay, that's all for the verification process. Now let's start the project and test this out. Our project is running. Let's switch back to Postman. Previously, we enabled multi-factor authentication. Now that is active, let's try to log in. We'll use our existing login tab. Let's send the request. Here in the response, we are getting a 200 status code, but the response body no longer contains the access token or refresh token. These values are null. Instead, we receive an MFA token. This is a temporary token we will use for login verification. You can also see that this MFA required is set to true and MFA verified is false. Before we use these, let's check what is stored in our database, specifically in Redis. Let's open the database tool. Here is our Redis instance. Let's refresh. You can see those old tokens are invalid because we enforced multi-factor authentication and forced the user to log out. As we tried to log in just now, a new token entry with this prefix MFA pending was added. Okay, now let's verify the login. Back in Postman, copy this MFA token. Let's open a new tab for verification. It will be post request. The URL will be localhost 8080 API auth verify MFA. In the body, make sure row is selected and JSON is chosen from the dropdown. Let's provide the JSON object. First, we need to provide the MFA token. So, paste the token, we just copy it. Second, we need the code. We'll get this code from Google Authenticator. Let me open the app on my mobile. Here, this code is generated. Let's use this one. Provide the code in the request body and send the request. Look at the response. We are now getting this access token and refresh token. This MFA token is null, MFA required is true, and MFA verified is also true. Now, if we check the Redis, let's refresh. You'll see the temporary token has been removed. Let's try to log in using this token. Copy the new access token. Go back to our first step and the authorization header. Paste the token. Send the request. Now we are getting the response. That is how we enable multi-factor authentication in our application. So we have successfully implemented multi-factor authentication in our application. This is much stronger than just relying on a simple password. But I want to point out a potential security vulnerability in this application. I want everyone to understand exactly how this works so we never make this mistake. First, let's look at the application.yml file. Here, for the temporary token, we set the expiry to 300,000 milliseconds. That is 5 full minutes. In security terms, that's an eternity. Let's check the Auth service. Navigate to the Verify MFA method. This is the potential point of real disaster. Here, look at this logic. When the user submits the wrong code, we throw this runtime exception, but we never invalidate the temporary token. Even if they get the code wrong, the 5-minute timer keeps ticking. The token is still alive in Redis. This means an attacker with a stolen password has a 5 minutes window to brute force the 6-digit code. They can hammer our API with thousands of guesses per second, and we never log them out. To fix this, we need to implement rate limiting immediately and invalidate that token after 3 failed attempts. This prevents brute force attacks from succeeding. I have already made a video on how to implement rate limiting, which you can see on the screen. This guide will help you understand the rate limiting concept and implement it in your project to secure your production application. I'll see you in the next video. Till then, bye bye.